Reuse and recycling is in line with the concept to enhancing circular economy. We know that linear economy results from business practices that assume a constant supply of natural resources. And we know that we are depleting in many natural resources. Also, we know the environmental implications of following this linear economy. So, why recycling? Well, we already know many reasons that we have discussed before why it is important to recycle. One of these reasons we will discuss more in detail. So, it reduces energy consumption, reduces pollution, and this leads to the reduction also of global warming, and reduces the amount of waste to landfills. And why is important to reduce the amount of waste that is being disposed to landfills? Because simply it's uneconomic. Uh, Costs to communities for operating and maintaining landfill sites are high, and the availability of suitable land is limited. You may think that this is really not the case in Australia, but actually, no one wants to have a landfill near um, your neighborhood. Um, so we need to think about also the typing fees that are constantly increasing for disposal of materials or waste. This increases the competitiveness of recycling options and actually rewards waste minimization efforts. To understand better why recycling is important, I'm showing you this example of the recycling of paper. The chart on the left side shows the process of throwing away 100 tons of paper. First, trees are harvested. Then logs are transported to a paper manufacturer. And once the paper is manufactured, workers use and dispose the paper. So trash is collected and the paper is buried into the landfill. That's the final destination. And the result of this is over 100 million metric tons of carbon equivalent. And then if we go to scenario number 2, where we recycle 50 tons of paper, the reduction of these greenhouse gases is significant. So first, fewer trees are harvested, fewer logs are transported to a paper manufacturer, and less paper is manufactured from virgin material. And workers use and recycle paper, which is collected and transported to a recycling facility. The recovered paper is remanufactured. So this results in 40 million metric tons of carbon equivalent. So the reduction is significant. And where we actually see the circular economy is from the workers use and recycle paper, right? From that till the following steps, we can see that we are enhancing a circular economy. So if we know that recycling has many advantages, why not enhancing recycling? Well, it's not that simple. For instance, recycling is subject to the market. So this is something that has been happening in Australia, where recycling companies have stockpiled thousands of tons of glass because there is no market for this glass. So it's there just standing there, and there no one have a proper use for it. In the past, China was the biggest market for recycling waste, but since 2017, it has restricted imports of Australian plastic, textiles, mixed paper, and also glass. And this is because of its high contamination rate. So we need to enhance the industry for recycling. Now, local councils are considering more and more the idea of implementing recycling facilities and also enhancing or promoting technologies where we can actually apply these materials. This is an overview of the solid waste management system that comprehends generation, storage, collection, transport, and disposal processing. The generation comes from residential waste, commercial waste, construction and demolition waste, institutional waste, and municipal service waste. Then we can have a storage or directly to have a collection system. We usually have also some transfer station that will send the material that cannot be recycled directly to landfill. In the collection system, we can actually the materials are sorted by the ones that are separated into the materials that are recyclable materials and the ones that goes directly to landfill. We have a material recovery facility, if there is, and then that's where we recycle materials. So what do we recycle and what are the waste generators? So in general, the residential and commercial waste generator are the generators along with the construction. So in general, the construction materials are separated or are not mixed with the materials that are recovered from the municipal solid waste. And from these two waste generators, we are going to recycle paper and cardboard, plastic, glass, metals, and construction materials. So we all know that plastics, paper, and glass is material that we have to recycle, but really, do we actually know exactly whether this material can be recyclable? We have so many symbols that we actually don't know, and not always all the materials can be recycled by the local councils. So this is a big problem because it generates materials that are considered pollutant in the material recycling and the facilities, and that cannot actually be recycled. Another important waste that is being recycled is the construction material. Building materials account for about half of all materials used and about half the solid waste generated worldwide. And we all know that they have an important environmental impact. And this is in every step of the building process, which means that it goes from extraction of the materials, processing, manufacturing, transportation, construction until the disposal at the end of the building's useful life. Landfill charges are an incentive for high recycling rates of these materials. Construction materials, also known as masonry materials, also include asphalt, bricks, and concrete. Well, as I said before, the charges enhance the recycling, but lately, also the high value of some materials embedded in this waste, such as metals and hardwood timbers, have enhanced or encouraged recycling practices. We can also reduce the amount of CO2 emissions and the reduce of the energy that is being also used for the extraction of these materials by recycling, only partially recycling these materials. And also it is important again to consider that it will enhance the circular economy. Another important waste that can be subject to recycling is electronic waste. Electronic waste includes all electronic appliances and also high-tech devices. And this, as I showed you before, is not classified as recyclable, but due to the high content of critical materials, it can be this can be a good alternative for obtaining high value materials. Also, some important things to consider are that 70% of the toxic chemicals found in landfill come from e-waste, and e-waste is being sent to landfills 3 times faster than general waste. E-waste is a global environmental problem due to the presence of these toxic substances. And it is a global problem because it doesn't matter if it's not really highly consumed in some developing countries, because they will actually be the ones who will receive the e-waste from developed nations. You can see the exports of e-waste in tons, where Asia, America, Europe are the biggest senders or exporters of e-waste. And then we don't know the final ending or the management practices in those countries. An important concept to link waste with energy and also recycling of materials is the term embodied energy. Embodied energy is the energy consumed by all of the processes associated with the production of a material. It goes from the mining and processing of natural resources to manufacturing, transport, and product delivery. It does not include, however, the operation and disposal of the building material. That will actually will cover all the life cycle approach. Embodied energy varies greatly with the different modes of making this material or a specific material. That's something important to consider. In many cases, like if we're talking about construction material, a higher embodied energy level can be justified if it contributes to lower operating energy. Can you think about how this can be explained? Well, for example, large amounts of thermal mass high in embodied energy can significantly reduce heating and cooling needs in well-designed and insulated passive solar houses. So when we are talking about well isolation in houses, it's better to probably have higher embodied energy values that will actually allow for a house not to lose or to have energy losses, right? Or and requiring, for instance, air conditioning or requiring heating. On the right side, I'm showing you the some common building materials and the embodied energy for making these materials. It's in megajoules per kilogram. As you can see, for instance, for aluminum, the embodied energy is significantly high. Also, for plastics, for copper, the energy that was required to extract and to obtain this material is very, very high. This table should be used with caution. And this is because, as I already explained to you, it depends on what was the approach for making this material. Also, in some materials, recycling is already included. So, for instance, in some cases, in some regions, aluminum also comes from some recycled aluminum, which decreases the embodied energy to make this material. when we start to understanding and to seeing these numbers on the energy that is being required to make these materials, we can actually now understand, for instance, that renovating an existing house rather than demolishing can have a huge impact on also recycling can have a huge impact on global warming, for instance. Now I can explain to you the CO2 emissions that are being generated for making a material. So we discussed before the energy, and now we are linking to CO2 emissions. What is the link? The link is the energy required, right? So these are the amounts of CO2 released when making or using a product. And you can see on the left side table that some materials have like 10 times or more or in order higher CO2 emissions than others, right? So this figure, this table actually put the things in perspective. So in the first column, we have the products made from virgin materials, and then we have the products made from recycled materials, and the products made from mix, and then the CO2, the weight of CO2 per weight of product, and the recycling savings. I can put as an example aluminum cans, right? And you can see that the CO2 emissions from a product made from virgin material is significantly higher than at least a mixture that reduced from 4.27 to 2.24, and the savings are 93%. So due to the obvious impact that CO2 emissions have on the earth, industry is being forced to reduce the emissions, right? The CO2, the greenhouse gas emissions. This is not always easy. So something has been created in order to offset their emissions by making finance readily available to renewable energy projects. So how does carbon credits work? Or this is also called carbon offsets. So carbon credits are typically measured in tons of CO2 equivalents and are bought and sold through a number of international brokers, online retailers, and trading platforms. These help businesses in mitigating their emissions and comply with the global standards. So you can, one of the example that you probably have seen is the airlines, right? When they actually ask you whether you want to reduce the amount of CO2 that is being emitted by paying something a little bit more, this is somehow the connection with the carbon credits. So it's not that they're going to reduce the amount of CO2 that is being emitted by flying. It's just that they're going to have a project where they can they may build or start growing trees or getting energy from renewable energy, or so a project that will reduce the CO2 emissions somewhere else, right? So on the left figure, this is like how the system of carbon offsets works. So a company that needs to reduce the emissions by credits, and these credits are like an investment for carbon offset programs that can include reforestation, renewable energy, or methane capture and combustion.